Have you ever watched an airplane soar through the sky and wondered, how do they do that? It's a question that has captivated people for ages. That moment when a massive metal tube defies gravity, lifting off the ground with grace and power, is nothing short of awe-inspiring. But how does this incredible feat of engineering actually work? Let's embark on a journey to uncover the secrets of flight. We'll explore the forces that allow airplanes to stay airborne, delve into the ingenious design of their parts, and uncover the magic that makes flying possible. From the powerful engines to the intricate controls in the cockpit, we'll break down the complexities of aviation into easy-to-understand concepts. So, fasten your seatbelts, adjust your tray tables to their upright and locked position, and get ready for takeoff as we unravel the mysteries of how airplanes conquer the sky. The key to an airplane's ability to fly lies in a force called lift. Lift is one of the four fundamental forces of flight, alongside weight, thrust, and drag. Lift is the upward force that counteracts gravity, the force pulling everything towards the ground. Without lift, an airplane would not be able to rise off the ground or stay in the air. But how does an airplane generate lift? This is a fascinating process that involves both physics and engineering. The answer lies in the shape of its wings. The design and structure of the wings are crucial to creating lift. Airplane wings are cleverly designed with a curved upper surface and a relatively flat lower surface. This shape is crucial. The curvature of the wing is known as the airfoil. When air flows over the curved top of the wing, it has to travel a longer distance than the air flowing underneath. This difference in travel distance is key to generating lift. This difference in distance creates a difference in air pressure. The principles of Bernoulli's theorem explain this phenomenon. The air on top of the wing moves faster and becomes less dense, resulting in lower pressure. Faster moving air means lower pressure according to Bernoulli's principle. The air below the wing, moving slower, retains higher pressure. This higher pressure is essential for creating lift. This pressure difference creates lift. The higher pressure below the wing pushes it upwards. The higher pressure beneath the wing pushes it upwards, overcoming gravity and allowing the airplane to climb into the sky. This is how airplanes are able to take off and stay aloft. The faster the air flows over the wings, the greater the lift generated. This is why airplanes need to reach a certain speed before they can take off. To truly understand how an airplane flies, we need to get acquainted with its main parts. An airplane, like any complex machine, is comprised of several key components that work together harmoniously to achieve flight. These components can be broadly categorized into three main sections: the fuselage, the wings, and the tail. Each of these parts plays a critical role, not only in generating lift, but also in maintaining stability and control during flight. The fuselage, essentially the body of the airplane, houses passengers, cargo, and some of the crucial systems. The wings, as we've learned, are responsible for generating lift. And lastly, the tail helps stabilize the aircraft and control its direction. Let's start with the fuselage, the main body of the aircraft. Imagine it as the airplane's skeleton and skin combined. It's the streamlined structure that houses everything from passengers and crew to cargo and fuel. The fuselage is designed to be both strong and lightweight, built to withstand the stresses of flight while minimizing drag. Inside the fuselage, you'll find the passenger cabin with its rows of seats, overhead compartments, and windows that offer breathtaking views. The cockpit, where the pilots sit and control the aircraft, is located at the front of the fuselage. This is the airplane's brain, filled with instruments and controls that allow pilots to navigate and maneuver the aircraft. The fuselage also typically houses cargo holds for baggage and freight, as well as fuel tanks that feed the engines. Section 5, the wings, catching the air. We've already touched upon the crucial role wings play in generating lift, but let's delve a little deeper. Airplane wings are marvels of engineering, meticulously designed to maximize lift while minimizing drag, the force that resists the airplane's movement through the air. The shape of the wing, with its curved upper surface and flatter lower surface, is called an airfoil. This shape is key to creating the pressure difference that produces lift. But wings are not just static structures. They have moving parts that allow pilots to control the amount of lift generated. These movable parts are called control surfaces. Ailerons are located on the trailing edge of the wings, and they move in opposite directions to control the airplane's roll, or its movement around its longitudinal axis. flaps, also on the trailing edge, extend downwards to increase lift, especially during takeoff and landing. Section 6. The tail, keeping it steady. At the back of the airplane, you'll find the tail, another crucial component for a stable and controlled flight. The tail is not just a simple appendage. It plays a vital role in ensuring the aircraft maintains its intended path and altitude. The tail is essentially the airplane's fin, providing stability and helping to control its direction. Without it, the airplane would struggle to stay on course, especially in turbulent conditions. It consists of two main parts, the vertical stabilizer and the horizontal stabilizer. These components work in harmony to keep the airplane balanced and responsive to pilot inputs. The vertical stabilizer, the tall, upright part of the tail, prevents the nose of the airplane from swinging from side to side, a motion called yaw. This is crucial for maintaining a straight flight path. Attached to the vertical stabilizer is the rudder, a movable control surface that pilots use to control yaw. The rudder is essential for making precise turns and adjustments during flight. By adjusting the rudder, pilots can steer the airplane left or right. This is particularly important during takeoff and landing, as well as in-flight maneuvers. The horizontal stabilizer, resembling smaller wings that stick out from the tail, helps to maintain the airplane's pitch, which is its up and down angle. This ensures the airplane remains level during flight. The elevators, movable surfaces on the trailing edge of the horizontal stabilizer, control the pitch. They are crucial for adjusting the airplane's altitude. Pilots use the elevators to make the airplane climb or descend. By carefully manipulating these controls, they can ensure a smooth and safe flight experience for everyone on board. Section 7. Engines powering the journey. So far, we've explored how an airplane generates lift and maintains stability, but what about the force that propels it forward? This is a crucial aspect of flight dynamics. That's where engines come in. They are the heart of the aircraft, providing the necessary power to move. Engines provide the thrust, the forward force that overcomes drag and allows the airplane to move through the air. Without this force, flight would be impossible. There are two main types of airplane engines: jet engines and propeller engines. Each has its unique mechanism and application. Jet engines work by sucking in air, compressing it, mixing it with fuel, and igniting the mixture. This process is highly efficient and powerful. This creates a powerful explosion that propels hot exhaust gases out of the back of the engine, generating thrust. The speed and force of these gases are what push the airplane forward. Propeller engines, on the other hand, use a spinning propeller to create thrust. This method is simpler but equally fascinating. The propeller acts like a rotating wing, pulling air through it and pushing it backwards, propelling the airplane forward. This action is similar to how a fan moves air. Both types of engines are marvels of engineering, showcasing human ingenuity and technological advancement. Jet engines are typically used in larger, faster aircraft, such as commercial airliners and military jets, due to their high-speed capabilities, while propeller engines are common in smaller aircraft, like private planes and regional airliners, where efficiency and simplicity are key. Understanding these engines helps us appreciate the complexity and beauty of flight, and the incredible technology that makes it possible. Section 8. Controlling the bird. Now that we understand the main parts of an airplane and how they work together, let's step into the cockpit and see how pilots control these magnificent machines. The cockpit is like the airplane's nervous system, filled with an array of instruments, controls, and systems that allow pilots to fly, navigate, and communicate. Pilots use three main controls to maneuver the aircraft: the control yoke or joystick, the rudder pedals, and the throttle. The control yoke, resembling a steering wheel, controls the ailerons and elevators. Moving the yoke left or right controls the roll of the aircraft, while pushing it forward or pulling it back controls the pitch. The rudder pedals, located on the floor of the cockpit, control the rudder, allowing the pilot to steer the airplane left or right. The throttle, usually a lever, controls the engine power, determining how much thrust the engines produce.